Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative. So as per the problem, determine the points of inflection for the function and determine the change of sign in the second derivative. So we are given the function y equals 25 over x squared plus 48. So inflection points are points where the second derivative of a function is equal to 0 or undefined. So we have to find the second derivative of this function. So we'll start with the first derivative. Now in order to find the derivative of this function, we should move the denominator x squared plus 48 to the numerator because there is no x term in the numerator, and that will make it easy to find the derivative of this function. So the first step is now we can find the derivative of this function using chain rule. So as per the chain rule, we have to find the derivative of the outer function first. Now 25 is the coefficient of the term, so that will stay as it is. And the outer function is the exponential function with the exponent -1. So as per the power rule, we'll move the exponent -1 to the front and then subtract 1 from the denominator, from the exponent. Times the derivative of the inner function, and the inner function is x squared plus 48. So the derivative of that will be 2x plus 0. So we can ignore the 0. Now we can simplify this expression. Now first we can multiply 25 times -1 times 2x, and that will be -50x, and times x squared plus 48 exponent -2. Now we can move x squared plus 48 in the denominator. That will make the exponent positive. Now we have to find the derivative of this y prime to get the second derivative of the given function. So as per the quotient rule, so we start with the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So for that we'll have to use the chain rule. So we'll start with the derivative of the outer function. So we'll move the exponent 2 to the front and subtract 1 from exponent times the derivative of the inner function, which is x squared plus 48. So the derivative is 2x plus 0. We can ignore the 0 over the square of the denominator. Now we can simplify the numerator. So in the second part, it become positive 200 x squared, because minus -50x will become positive 50x. So positive 50x times 2 is 100x, and 100x times 2x is 200x squared. and then times x squared plus 48, exponent 1, but we don't write 1 as an exponent. And in the denominator, we can use power on power law of exponent to combine the exponents. So we get x squared plus 48 exponent 4. Now for inflection points, we can sub in y double prime as 0 and then solve for x. So we can continue here. So we get 0 equals negative 50 times. Now we can cross multiply the denominator to the left side. So that will become 0. Now we can solve this equation by doing common factoring. So we can factor out negative 50 x squared plus 48 from both terms. So in the first term, we are left with x squared plus 48. And in the second term, we are left with minus 4x squared. Now we can simplify the terms in the second part. So we can combine like terms. So we get x squared plus 48 minus 4x squared, and we can combine x squared and minus 4x squared. So we get negative 3x squared. Now we get two cases. So we can set the factors equal to 0 and solve for x. So the first factor is x squared plus 48 equals 0. And now we can isolate x by subtracting 48 from both sides. So the 48s on the left side will get cancelled out. So we get x squared equals negative 48. Now square of a number cannot be equal to a negative number. So from this case, we get no solution. Now we can analyze the second case. So we can subtract 48 from both sides. So the 48s on the left side get cancelled out. So we get negative 3x squared. Now we can divide both sides by negative 3. So the negative 3 on the left side get cancelled out, and we get x squared equals 16. And now we can apply square root to both sides. So we get x equals plus minus 4. So now to find the inflection point, we'll have to sub in these x values one by one in the given function to find the corresponding y values. So let's start with x equals negative 4. So if we sub in x equals negative 4, we get y equals 25 over negative 4 square plus 48, which is equivalent to 25 over, so negative 4 square is equal to 16, and 16 plus 48 is equal to 64. So the first inflection point is negative 4 and then 25 over 64. So this is the first inflection point. Now we can find the second inflection point by subbing in x as positive 4 in the y equation. So y equals 25 over 4 square plus 48, and 4 square is equal to 16. So we'll get the same y value, 25 over 64. So the second inflection point is 4, and then so these are the two inflection points we got by setting the y double prime equal to 0. Now y double prime will not be equal to undefined for any x value, because there is no x value that will make the denominator of y double prime equal to 0. Because x squared plus 48, if we set it equal to 0, I can show you on this side, and if we isolate x, so we get x squared equals negative 48, and there are no x values that satisfy this equation. So therefore, this function has only two inflection points. Now we have to determine the change of sign in the second derivative for both inflection points. So let's start with the first inflection point. So negative, so I can use a different color. So negative 4, 25 over 64. So we have to determine the sign of y double prime on the left and right side of this inflection point to find out whether the curve is concave up or down on the left and the right hand side of this inflection point. So we'll use the y double prime equation. So for the left side, we can use the x value as 4.1, and for the right side we can use negative 3. So we can sub in these x values one by one in the y double prime equation. So y double prime equals, so we get negative 50 and then negative 4.1 squared plus 48 and then plus 200 times negative 4.1 squared times negative 4.1 squared plus 48 over negative 4.1 squared plus 48 and then exponent 4. Now we can evaluate this expression. So we just have to see if the y double prime is a positive or a negative number, because if the y double prime is negative, that means the curve is concave down, and if the y double prime is greater than 0, that means the curve is concave up. So in the numerator, we can first evaluate negative 50 times negative 4.1 square plus 48 and then square. So I got negative 210,016.805 and then on the other side, so we got 200 times negative 4.1 square, and then parentheses, the negative 4.1 square plus 48, and then close the parentheses. So I got 217891.22 over a positive value. So in the numerator also, we'll get a positive value. So positive over positive will give us a overall positive value. That means on the left side of this inflection point, the curve is concave up. Now we can do the analysis on the right side of this inflection point. So we'll use the test value, negative 3.9, so y double prime. So negative 50 times 3.9 square plus 48 square plus 200 times negative 3.9 square times negative 3.9 square plus 48 over, so negative 3.9 square plus 48 and then exponent 4. So the denominator will be a positive value. Now we can start by evaluating the numerator. So the first part is the negative 50 times and then negative 3.9 square plus 48 and then close the parentheses square. So I got negative 199,775.205 and then plus, so now we get 200 times negative 3.9 square and then parentheses negative 3.9 square plus 48. So I got 192284.82 over a positive value. So in the numerator, we'll get a negative value. So negative over positive, which will give us an overall negative value. That means the the curve is concave down on the right side of this inflection point. So as we go from left to right, the concavity of the function changes from up to down as we pass through this inflection point. Now we can analyze the other inflection point, and that is 425 over 64. So now on the left side of this inflection point, we can use the test value 3.9 and on its right side we can use 4.1. Now if you analyze the y double prime function, all x terms in this function are squared. So that means the result that we got for negative 3.9 will be the result for positive 3.9 as well. So that means on the left side of this inflection point, the y prime will be a negative value. So therefore, the curve is concave down on the left side of this inflection point. And for positive 4.1, so the y double prime will be a positive value. That means the inflection point, the curve on the right side of this inflection point will be concave up. So as we go from left to right through this inflection point, the concavity of the curve changes from down to up. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.